Hello students, good morning to all. Welcome to online class. So till now we have discussed about AC current, DC current and working of transformers and lot more things. In this class we are going to learn about the working of inverter and what is an inverter and its types. So without any delay, let us go into the class.
In this class, we are going to discuss about inverter. So coming to the topic of inverter or power inverter. Inverter is an electronic device or an apparatus that changes the direct current into AC current. So the concept of inverter is to convert the DC to AC. So let us check how DC is converted into AC and types of inverters and working of inverter and some more things. So without getting late, let us start our video. In this topic, we are speaking about inverter. So coming to the definition of inverter, we have a power inverter or an inverter is an electronic apparatus that changes DC current to alternating current. The working of inverter is to change DC current to alternating current. That means, if you observe this graph, this is the graph of direct current, that is DC current. So this is the graph of DC current and this is the graph of AC current. So this DC current is converted into AC with the help of inverter. So let us discuss the types of inverters. So coming to the types of inverters, here we have three types of inverters depending on supply and output waveform and input source. So according to the supply, we have two types of inverters. They are single phase inverters and three phase inverters. Next, coming to the waveform, output waveform, we have square wave inverters, pure sine wave inverters and modified sine wave inverters. According to input sources, we have current source inverters and voltage source inverters. So now let us see the working of this inverter. Before entering to the working of inverter, let us discuss about the working of a transformer. Transformer is a device which works only on AC current, right? It won't work with DC, right? So what I am doing here is, let us take a battery and connect it to the primary source or primary coil of the transformer. What happens? The flow of electrons will take place, right? And there is a field generated in the coil, right? So the field created by this battery will be the form of this wave. So what I am doing here is, I am just switching on and off the battery source which is connected to the primary coil of the transformer. What happens here? See, when you on and off continuously, there is a change in the field created, that is getting on and off. It is not a continuous field, it is getting on and off, which results in the flow of current. This current is not be used by every electrical appliances. Okay, so and I have one more idea. Instead of using only one switch, I have placed two switches here, S1 and S2. So when I am switching on the S1, the current is traveling to this switch and entering into the coil S1. And when I am offing this, the current will flow through the switch S2 and it enters the coil S2. what is happening here? We are indirectly changing the field here. Changing the field, nothing but the polarities, so that there is a change in magnetic field is created in the primary coil, which results EMF in the secondary coil with the help of mutual induction. So this concept is used in the inverters. So this on-off switching should be done depending upon the frequency we need. So if we need 60 edges of frequency, we have to switch on and off 120 times in a second. If you need 50 edges, the switching should be done 100 times in a second. To do this, we need semiconductors, that are MOSFETs or transistors. So let us see how these MOSFETs or transistors will do this work. So I have a battery here. I have 4 switches arranged like this, and a coil that is given the load given to the transformer, and we have bulb here. So when I am allowing switches S1 and S4, I am switching on S1 and S4. So the current flows like this, and enters the coil, leaves the coil. So it's shown here. So the battery was switched on, switch 1 and switch 4 is on. So the current flows like this, and the direction of current is in this way. So we get this waveform. Okay. So next, I am switching off S1 and S4. Now turning on the switches S2 and S3. What happens here? The current flows in this direction and leaves the path with S3. So this was explained here. So here the direction of current is in this way. When we switched on S1 and S4, it was in this direction. So by switching on and off, this direction is changing. So changing fields is generated, which causes EMF in the coil. Here the produced wave will be in square wave, because we are just doing on and off. That means if we consider a DC voltage like this, what was happening here? We are offing it, and again we are switching on and allowing some time. Again we are offing it, and again allowing, again off. This is the waveform we are getting. So to work AC electrical appliances, we need a perfect square wave. So how it can be achieved? It can be done with the help of pulse width modulation. That means the width of the pulse should be modified. The width of the pulse should be modified. That means this switching, the on and off switching should be done carefully and with respective of time. That means what I am doing here is I am just switching on and off, and again it is allowing some extent of time, and then extending time some more and reducing again. So if I take average for this, it will be like this. Okay, we draw here. What I am doing is this: on, off, again on, some I have extended the time, and again off, and again on, extending some more time, and off, on, off, off, and again on, off. If you consider average for this, it will be like this. The average will be like this. So what I am doing here is taking the average value. This will result like this. It is the modified sine wave. So from this we can consider the perfect sine wave, which results. This modification is done with the help of comparators. These comparators will allow the MOSFETs or the transistors or the semiconductors which are doing the switching on and off. They compares the result with the input voltage and allows the switching. So hence we can define inverter is a converter. Inverter is a converter but not a generator. Inverter is just a converter. If you not connect any value to the inverter, it won't do any work. When you connect the DC current to the inverter, it will convert the DC current into AC current. So this is the working of inverter. Okay? So this is the working of inverter. Inverter is a electronic component or a device which converts DC to AC, so that we can get a square wave. The square wave is modified with the help of pulse width modulation, with the help of the comparators. So the square wave is converted into the sine wave. This is nothing but the AC voltage. Thank you.